Hello, Chemistry 30s. Welcome to part 3 of Outcome 1 for equilibrium acids and bases. We're not talking about the acids and bases yet, just focusing for now on the equilibrium portion. So today we're going to talk about Le Chatelier's principle. This is a French name, so make sure to have that French pronunciation. It's not Le Chatelier's, it's Le Chatelier. So we're going to talk about his principle, and essentially we're going to start with controlling the extent of equilibrium by manipulating properties is very desirable because it leads to more efficient and economic processes. According to Le Chatelier's principle, all right, so there it is. When a chemical system is at equilibrium, is disturbed by a change in a property of the system always appears to react in the direction that opposes the change until a new equilibrium is reached. Using a simple and completely empirical approach, chemical engineers could produce more of the desired products, making technological processes more efficient and more economical. So Le Chatelier's principle and the concentration changes. An increase in the concentration of the products or reactants favors the other side of the equation. For example, we have N2 reacting with H2 to produce NH3. So an increase in N2 or H2 will shift the equilibrium to produce NH3. So if we increase either of these, we'll shift the equilibrium to produce more NH3. If we increase our NH3 concentration, it will shift the equilibrium to produce the reactant. So it'll actually cause our reaction to go the other way. A decrease in the concentration of the products or reactants favors that side of the equation. If you take away products, more products will form. If you take away reactants, more reactants will form. So let's say you decrease this, so you're taking away that product, more will form because it's going to shift that way. Little note for you to read on about collision reaction theory, and concentration changes on page 692. We're going to keep rolling here with Le Chatelier's principle and temperature changes. So energy is treated like a reactant or product. For example, we can have reactants and energy to produce products, which is endothermic, and we can have reactants produce products and energy, which is exothermic. So just a quick reminder here, this is delta 8 of the reaction is positive. Delta H of the reaction here is negative for exothermic. So heating or cooling a system adds or removes thermal energy from the system. In either situation, the equilibrium shifts to minimize the change. If cooled, the equilibrium shifts so more heat is produced. If heated, the equilibrium shifts away from the heat, so it cools down. A little bit more on the collision reaction theory and a video for you to check out. Le Chatelier's principle and gas volume changes. With gases, volume, pressure, and concentration are related. An increase in pressure caused by a drop in volume causes a shift towards the side of the equation with fewer moles. So we have N2 reacting with H2 to produce NH3. And so we have more moles over here, so it will shift to NH3. Increased pressure causes a shift to the right, which decreases the total number of gas molecules from 4 moles to 2 moles, and thus reduces the pressure. If the number of moles are the same on both sides of the reaction, a change in volume pressure has no effect. So we can actually graph this so that we can reflect what is happening in these reactions. So here we have CCl4 reacting with HF to produce CCl2F2 and HCl. So the reaction establishes an equilibrium that is disturbed at the time indicated by the vertical dotted line. So this line here they're talking about. Well, the concentration of both products increases until a new equilibrium is established and concentrations become constant again. Note that the concentration of HF at the new equilibrium is greater than at the original equilibrium. So the imposed change is only partly counteracted. The initial Kc value and final Kc value are the same. All right. So that is what happens when we decrease our HF concentration or we increase these other ones to cause the HF to come down. We have another one here, just doing the same thing. Take a look at that. These are both looking at concentration changes. Here's energy changes. Here's volume changes. I encourage you to take a look at that. We have a summary here about a variables affecting chemical equilibria. So concentration, the increase shifts to consume some of the added product. Again, you can take a look at some of these and a little practice question here for you to do. We're going to look at some examples here though. So we add fluorine ions to HF to produce H plus and F minus. And so what happens is we added F minus ions. What happens is that causes our equilibrium to shift to favor the reactants because it's going to produce more HF. We're removing H plus ions, so those are being removed. Our reaction is going to favor the products. We have heat over here, and we're adding more heat. This is going to cause the reaction to shift this way to the reactants. And this will cause the SO2 to increase, but our SO3 to decrease. I guess I should have specifically circled these arrows here. They just worked out to be on that side. We add heat here. What happens is that our reaction is now favored on this side, which is products. And our CO2 production, it will go up. We increase our pressure, so make sure our reaction is balanced. These are a 1 to 1 to 1. And so when we increase the pressure, we have 1 mole here and 1 mole there and 1 mole there. We have 2 moles here, we have 1 mole over here. This means that because if we increase the pressure, it'll go to the side of the fewer moles, so it will favor the reactants. Our PCl3 will increase. It would decrease. Our PCl5 would increase. All right. And that concludes outcome 1 for this unit. And then please do the corresponding assignments that are posted on Google Classroom.